The objective of this project is to add an external lamp, in this case, to this camera. And this camera is night colored, which could be any analog, even analog cameras with may have this function of night color, and this means that the camera will record in full color during dark or even in nighttime. It's important to mention that everything that we're going to be discussing will be included outside of the camera, actually. That means this circuit and of course the lamp, the exterior lamp, and basically the only function from the camera is to turn on and off this lamp, which actually means that there is a detection through in this case this camera, this particular camera, this Dauha, it has smart illumination, which means the light will turn on only during nighttime. But I'm gonna be using an external components which will be included outside of the camera, and we need to warrant that will only turn during nighttime. So that's why we'll be seeing this circuit, which actually has two different stages. It's the one for the input is there is what is called a light dependent resistor, a photoresistor, which will be basically the function of a photoresistor. It will change the value of the resistance based on the intensity of light that will shine on top of it, on the sensor. Basically, when it's dark, the resistance is very high. It's actually in the mega ohms range, and when it shines light over it, it could go as low as the kilo ohms, 10 or maybe 20 kilo ohms. So as you can see, there is a different value depending on the amount of light that will shine over it. So basically we have two stages on it. It's as I mentioned, the first one is to warrant that it will only turn during dark scenes or during nighttime. And the second phase, the second part of this circuit, is actually another LDR, light dependent resistor, which will be controlling through a resistor the function of this. This is a timer relay, which has, as you know, this has a triggering action, and based on the changes of voltages that it may have at that gate, it could be positive or negative, it will turn on the countdown. In this case, it will turn on the relay as well as a countdown of the time that the relay will be operating or turn it on, and that's the time. Since we have 12 volts, the voltage actually came from the same power from the camera, is the one that we're using in this case to turn on this particular project. This camera is a 12 volts lamp, a spot lamp. So as mentioned, this photoresistor or LDR, light dependent resistor, the idea is to be connected here in front of the lamp. And as I mentioned, anytime the camera will detect motion, it will turn on the lamp, and the idea is to record in full color. That's why at least Dauha is called night color. It could be a smart light, basically. So the camera, the idea of this project is that you don't need to open the camera to do any modification, DIY or soldering, or even in a PT or PTC camera could be more difficult to include to take out all the signals that we may need to control. And that's why I presenting this project, in order that you don't need to open the camera, and that of course that will void the warranty as well. So This is the whole idea behind this presentation. So let me start. Let's say, for example, let me show you the first stage. Let me discuss the first stage that we have. As you can see, this is like the, let's say, the warranty that the camera will only operate, or not the camera, the light will be turned on only during dark scenes or during nighttime. Okay, what we're using here, it's as you can see, there is LDR. As I mentioned, it's inversely. The proportion is inversely proportional in terms that the more light, in this case, the lower will be the resistance. As mentioned, this is about 1 meg when it's fully covered and or dark, and it will go 10 or 20. I will later give you all the components that I use for this presentation. And this is a fixed resistor. This is a 150K resistor and an NPN transistor. NPN means the base is positive. This is a 2N2222, very common and very easy to find. Basically, it's both are connected through the base, and it's a voltage, the voltage divider that will be, in this case, when we cover. Let me, if I cover, it will turn on. Let me disable this part of the circuit, which is used to control the external lamp. So as soon as I put the cap, just for demonstration, it will turn give a forward bias, in this case, to the transistor. So this transistor will be conducting actually the same voltage from the camera, which is here in the collector. So when it's forward bias, then you know, the bias will be when we have a positive voltage between the voltage between the emitter and the base. When it's over it will forward the transistor, and you will have the, let's say, the 12 volts that we have from the collector will be then passing through this this case, as I mentioned, the emitter is connected directly to this is our electronic relay. It's a single post, single throw. So actually the contacts are open except when you apply voltage into it. This is a 12 volts. When it apply voltage, then the contact will close and it will pass voltage to the second stage, which is here. This stage, as you can see, we have a voltage that goes, this is the output of the connector. It will go directly to the voltage, the VCC from the, in this case, the relay timer. And the other voltage goes through this transistor. As I mentioned, it has a resistance also in parallel. It's a circuit in parallel connected to the, in this case, connected to the base. So we have the same here. We have the photoresistor or light dependent resistor. Again, the same 150K. In this case, the different. This one goes through ground. In the other, the resistance goes into VCC, the power. So basically, what it's waiting here, it's the shining from the lamp. When it detects motion, it will turn on the lamp, and it will shine over this LDR, and it will change again, will enter into conduction, and at that time it's when it will turn on the transistor, and it will apply, besides turning on the through this emitter is connected to the gate or the triggering gate of this timer delay. So when the shine goes here, it will turn on, apply voltage, and that's when it will turn on the relay. The relay again will pass the 12 volts directly to the lamp will turn on. And that's the process of the triggering. Actually, it's the countdown process, depending on the adjustment that you made to this is a potentiometer, and depending on the settings that you have on this connector, you may have it in second, minutes, or even hours to keep it turned on the lamp, external lamp that we are connecting to it. So basically, if I remove this cover, the process will start, and that means that when the camera detects motion, remember I mentioned that this is a night color camera with intelligent. It's an SMD in terms of Dahua. It's using what is called smart motion detection, in which you have covering different areas, different zones that you want to protect, and even vehicles or humans that will enter into that protected zone. It will turn on even send a notification and turning on this light. The purpose, as I mentioned, to record in full color. When that happens, then it will change this. It will putting an enable into this part of the circuit, the second part of this. Remember, this is just to warranty that it's during nighttime exactly, and this one is to detect the process of the detection. And remember, it's going to be connected here in front of the in front of the lens, the lamp of the camera, and the connections basically goes into this circuit that you will be including in a junction box. Even it could be the wall or the ceiling, or any box that you will be protecting this circuit that you're going to be preparing with all these components. And in this case, let me start the process just to understand. As soon as I remove the indirect, this camera is disconnected. It's actually just for demonstration, but I have enough light from the recording camera that I'm using, the lamp that I'm using for recording. So will be enough light to be shining into this FDR, and it will turn on and give enable. It will enable this part. So let's open it. As you can see, the lamp will turn on, and it still hasn't. The countdown hasn't started yet, because since there is a shining light into it, there's no transition being detected at the gate, at the triggering. So basically, it doesn't matter how many minutes, how many time it lasts, the detection, the area, someone moving or whatever, it will stay with the lamp on. So it could be 5, 10, 30 minutes, something being detected by the camera, the lamp will still be on. I need to mention that as soon as I covered by covering this LDR, it means that it sees the motion, it no longer detecting motion, and this lamp will turn off. So actually, when I cover the LDR, this LDR, light dependent resistor, now the gate will receive a transition, and that's when they'll start the countdown. I program for 30 seconds only for this demonstration, but normally, as mentioned, it could be minutes, even hours, that you can keep it, the lamp turned on. Normally, for this presentation, I mentioned 30 seconds, but normally you have 2 or 3 minutes or 4 minutes being turned on, in order for us, it's actually considered light as the best deterrent we can have against a burglar. You may add different lamps to be connected to this circuit. One thing that I need to mention, if you have a 12 volts lamp to be connected, like in this circuit, you should not use the same power from the camera, because it will lower the voltage, and eventually below the 11, it depends, 11, 10 volts, it will turn off the camera. So if this is the case, that you'll not be using a voltage from the camera, never use the same power from the camera. Use a separate power supply. Or even better, I will recommend using an AC lamp, like a spot lamp. 120. In my country is 120 volts AC. It's better to use like 100, 200, 300 watts LED, which actually it's the amps that it requires is quite small in comparison. This one that I'm using just for this demonstration, this lamp, as I mentioned, is only 12 volts, and the power of the camera, it's it's only 5 watts. So it means that it's only taking half an amp, so 0.5 amps. The circuit is actually 1.5 amps, but I recommend, instead of using this one, if you plan on using AC as well, try to use an optocoupler circuit, which include the relay, include the triggering positive, negative, include as well the timer as well. So it's better to use a separate one, and normally that goes between 10 and 15 amps. So you may put down easily any kind of illumination that you may have, a circuit of illumination like AC. And actually the relay support AC or DC in that same quantity, 10 or 15 amps. So I recommend better changing it. I will include circuit with the value of all these components in case you need to test, do some testing to it or change it. But remember, the most important thing is that you may add for any smart color or any night color camera that may have an external lamp. That's the case of a night color, even analog, or in this case an IP or digital cameras. So you may add it to the circuit. So I will leave a diagram of the connection with all the values of the components.